Now, when we heard about the burette, we found out that it was a volumetric piece of glassware and could tell us the actual volume it was dispensing very accurately. But notice that we're going to be staying between 1 milliliter and 50 milliliters. That's a pretty big set of volumes. Now, how do we know a measurement even better? And how do we have dead-on measurements each time? Because remember, we have some accuracy and some precision issues when we use this one. Enter the volumetric pipette. Now, they come in a wide range of volumes, and here I've got a 10 milliliter. Here I've got a 1 milliliter. Over here in this next hood over, you can see that we have 25 milliliters, and there's even a 50 in there. Oh no, that's a 20. We can get ones that go as far as 1 liter. Now, that's great, except that these are expensive. This one, ballparking, this one's probably 30 or 40 bucks. Some of the more expensive and very large volumes that are high quality can go into the hundreds easily. $300 or $400 for this shatterable piece of glass. So you'll notice that I'm keeping it corralled between this base and the lip at the edge of the hood so it can't roll around and I don't have to worry about it. Always make sure you set something on each side of it so they don't roll around and fall off your table and break. That's an important piece. Now, we're going to focus on the 1 milliliter, and then I'm going to come back to the 10 milliliter in a second. But before I do, I thought I'd talk about some different varieties of pipettes that we can have. These are called volumetric pipettes, and they give us a really high quality volume measurement. We can also have some graduated pipettes. And there's two types. There's the ones that are just called graduated pipettes, and then there's these. This particular one is called the Serological Pipette. Serological pipettes are very much like the other. It's just that this one kind of has everything, so I'll show this one instead of the graduated. Now you notice our zero marking is right here, and there's some negative values above it. Be very careful about that when you're doing your measurements, if you're using one of these. Now you'll notice that we do have tenths places explicitly marked, so we should be able to estimate one more place. We should be able to get 3 to 4 sig figs from this, depending on how far down we are. Probably 3 sig figs, 2 decimal places. Now, with these more expensive ones I'm about to show you, you say, well, those only go to 2 decimal places, and you're right, but it's a question of accuracy and precision. This one's not going to be so accurate or so precise. It's going to have a bigger error bar on it. And that's when we start having to use significant figures less and less, and use statistics more and more. So be aware of that. Serological ones are nice. This is actually a plastic one that can't be shattered too easily. These are semi-disposable. We can reuse them. If you're working in a biological or medical laboratory, there's a decent chance you're going to treat them as disposable because there may be contamination, and that's a bigger worry than the, I don't know, dollar that they each cost. If you're doing chemistry, however, you're going to be staying with glassware. And glassware costs a lot more. And it has a higher quality. Now let me look at this 10 milliliter with you. You can see that there's this A at the top. That tells us the quality of the glassware. There's a category A and B. And you look up their accuracy and precision in a special chart for each of these, if you want to know more about them, or if you want to go purchasing and you want to know which one you're actually going to buy. It's a little hard to get this into the right light. Here we are. Okay, there we are. Now you can see it. So you can see it says 10 milliliters, TD, so this is to deliver, 20 degrees C, plus minus 0.02 milliliters. In other words, you will get 10.00 milliliters, plus or minus 0.02. Don't go writing it that you delivered 10 milliliters as 10.02. If you're deliberately over-delivering, come talk to me, because we got to fix your technique. You're trying to put 10 milliliters dead on. It's just the glassware is going to be plus or minus 0.02. So you call it 10.00 with an error bar of 0.02 is the precision of the glassware itself. Now, we want to fill straight up to the line, and you'll notice that if we're offside a little bit, you'll be able to see the ring going around it. That's a bad thing. You want to be seeing the line curled around, front and back, totally lined up. When it's totally lined up and the meniscus is dead on in between it, you actually have 10 milliliters at the quality of this glassware. Anything less, you've got 10 milliliters at the quality of your hands, and in this case your hands are kind of garbage compared to the quality of the glassware. Now the meniscus, remember the meniscus dips down like this. You're going to be reading at the bottom of the meniscus, because over here on the sides, what you've got is the attraction of the water to the silicon dioxide surface. So it's going to creep up a little bit, called capillarity. We don't care about the capillarity, it has been calibrated for that. Now, that said, I'm going to go ahead and set this into water for a second. Notice I didn't immerse it that far. Well, let's see if we can even see the pink. A little too hard to see on the 1 milliliter. Let me go for something a little wider, like the 10. Okay, and this is going to be a real test of the skill of my hands, how much dye we have in there, and the quality of the camera. You might be able to see a little pink droplet remaining on the inside of this tube. And actually, if we had sucked it up further, let me just go ahead and do that. You'll see that we have, there we are, see it dribbling out. That's a little more like it. We typically have a larger volume remaining behind. And as I go between black and white, you can see it a little bit easier. This was calibrated to contain that droplet. Not the one sitting on the outside. The one on the outside had better be delivered. But the one right there on the inside, it was calibrated, let me remind you, to contain, sorry, not to contain, to deliver at 20 degrees C. To deliver. In other words, the piece left behind is fine. It was calibrated to deliver it to its final destination. Leave that droplet behind. If you deliver that, if you blow it out with your pipette bulb, you have screwed up your measurement. Now, that said, in between, when you're cleaning them out, you need to make sure you suck out that droplet. And a great way to do that, use a paper towel. If you touch it up against it, capillary action will just wick it right out. Now what you'd want to do to really rinse this out, you'd go grab some DI water, suck it up, blow it out, suck it up, blow it out. You're in good shape now. That's how you want to clean one of these. But remember that on the label, to deliver or to contain. This is to deliver glassware. Same thing with our 1 milliliter. Now, 1 milliliter is the smallest you're typically going to work with in the lab. There's also a smaller kind of glassware called Lambda Glassware. If you see something with a little lambda sign on it, remember you've run across lambda if you're in Gen Chem when you talk about light, and if you're in analytical, you've probably come across wavelengths again and been reminded of the character lambda. Lambda glassware is listed in microliters. So you can actually deliver very tiny volumes, but that one gets really tricky to use because you're trying to deliver really tiny volumes, fractions of a drop. So you'll need some serious practice with that, and it's not going to be something we bring up in this video a lot. Now, when we go to use pipettes, we've got our very trivial pipette bulb. Now, let's see if I can do this one-handed. This is not trivial, so I'm going to have to cheat a little bit with my camera hand. There we are. We put the bulb, we blow out the air ahead of time, we set it into place, and then we start sucking volume up, and you can see it rising up. I don't have a very good seal with it since I'm working with one hand. But that's what we would normally do. People generally kind of hate using these bulbs, but I think that they're perfectly fine. I'll show you a trick on it though. Let me just suck some more up. If you have a large volume, you're probably going to have to do it a couple of times to fill up the whole thing. And a 10 milliliter is a fairly decent volume for this. Yeah, I'm going to pause the video and fill. Okay, back from the pause. Now you can see that I filled it up so that I'm way past the line. That should remind us that we always want to clean it out more than the line. And right there's the meniscus if you're having a hard time seeing it. See if I jiggle it, you can spot it a little easier. You always want to go past that line. Why? Because you want to end up right there at the line when you're done. And when you actually move it over to the other vessel, your fingertip may still be leaking a little bit, or the pipette bulb may be. And it's going to be dribbling out a little. In fact, you can even see a little droplet hanging there. I want to get rid of that droplet by touching it back on the wall of my source vessel. Now I'm ready to go and try to get volumetric. Now what I want to do is just roll my fingerprint over a little bit until the meniscus just barely starts to creep. That's a little hard to do holding a camera. There we go, see it moving? I went way faster than I meant to. Right there I am. Hey, not too bad for holding a camera and doing this at the same time. Get rid of your hanging droplet. Verify that you really do have your line at front and back lined up with the meniscus, and you can see I'm just above it. For the purpose of this video, I'll treat that as a victory because, like I said, too many things in my hands, and also because you can see exactly what you're looking for the meniscus matching up. Now you go over to your other vessel. We'll just pretend this is my target. You won't put it into the liquid. You'll hold it above it. You let it dribble out. You want to blow it out. I know you do, but you don't really want to. You want to let it go at its own speed. Because if you're blowing it out with a pipette bulb, you're not going to end up with that calibrated drop remaining inside. Remember, to deliver. Now what we do is we come over to the wall, just touch it off like this, take it away. Now if you care about that and you can't add any water, you just take this and you kind of roll it around like that to rinse everything back down in. That would be the right way to use one of these using one of the simple bulbs. Now, the next thing that people like using are these pipette pumps. I'm not a fan. Thing is, if you're going to use them, make sure you grab the right one. Each of these is rated for a different size. I use them so infrequently I don't even see the size rating on them. But each one of these has a different range. What you're going to do is you're going to put your pipette in there. You're going to use the thumb wheel here and use this to pump up the volume. When you're ready to go, you take it over to your target vessel and you push on this little cap and it just starts draining out. Not bad, but I can do better with my fingers on those blue pipette bulbs. If I'm going to use something different, the one that I will sometimes use is this kind of a bulb. Now you'll notice that there's three little spots here with a letter. There's this E, there's an S, and there's an A. And actually I'm holding it upside down. There we are, sorry. We have an A, we have an S, and an E. A, I forgot what aspirate. If you hold in on that, there's a little ball bearing on the center. When you squeeze it, it lets you squeeze it out. Kind of like the valve on a raft. Now you've got it sucked out and it's ready to suck up. S would be for suck. You put your pipette in here, put it into place. You suck by pressing in on the S. You'll notice the bulb starts to inflate. It would go a lot slower since you're actually drawing a solution through that tiny little hole, but I'm just demonstrating it quickly. When you're ready to drain it, you hold in on the E for evacuate, and then it'll just drain down just like the little thumb cap right here did. Those are just allowing it to evacuate into your vessel. So that's the trick of using volumetric pipettes. If you do it like this, you'll actually have really, really high quality measurements. The kind that lead to pharmaceutical grade measurements, and the kind that doesn't kill people if you're working in medicine. So, with that kind of a aside, that gives you an idea of why you want to get this polished and practiced.